Good morning to everyone. Welcome to my YouTube channel. Myself, Likith. Today's topic is PAM and FDM. Pulse Amplitude Modulation, Frequency Division Multiplexing. What is multiplexing? Multiplexing is referred as the combination of information streams from multiple sources of transmission over a shared medium. Multiplexer is a mechanism that implements the concepts. Demultiplexing to refer the separation of combination back into the separate information streams. Demultiplexer to refer the mechanism that implements the concept. Figures illustrate the concept. Each sender communicates with single receiver. All pairs share a single transmission network. Multiplexer combines information from sender for transmission in each way that multiplexers can separate the information for the receivers. Concept of multiplexing. You can see the diagram where the senders are sent to the multiplexer and shared by a single medium, and demultiplexer is like you receive the different number of which is equal to the sender. Need of multiplexing. Transmitting two or more signals simultaneously can be accomplished by setting up one transistor receiver pair for each channel, but this is an expensive approach. A single cable or a radio link can handle multiple signals simultaneously using a technique known as multiplexing. Multiplexing permits hundreds or thousands of signals are combined and transmitted over a single medium. Cost savings can be gained by using single channel to be used as multiplexing information signals. You can see the diagram where multiplexer combines all the inputs into a single signal. Demultiplexer processes the input signal and individual output is given. The main purpose of this multiplexing network is where the n number of input signals are joined in the multiplexer, and it is passed through the single channel and it is received to the different outputs. Frequency division multiplexing. Separate of this spectrum into small frequency bands. Channel gets band of the spectrum of a whole time. Advantages: no dynamic coordination needed. Work also for analog signals. Disadvantages: waste of bandwidth, is traffic distributed unevenly, inflexible guard spaces. Frequency division multiplexing. Each signal is located a different frequency band, usually used with analog signals. Modulation equipment is needed to move each signal to required frequency band. Multiply carrier are used, each is called subcarrier. Multiplexing equipment is needed to combine the modulating signals. You can see FDM process where modulator F1, modulator F2 and modulator F3 are added to it, and the single FDM process sine wave is given. FDM demultiplexing is a signal where the output is filtered out and separated into demodulator F1, demodulator F2 and demodulator F3. This is the image where FDM works out, where the message are the inputs. Low pass, it is passed through the low pass filter, and communication channel is synchronized, and the common channel medium is given, and communicator where it is again passed into low pass reconstruction and message is given as the output. FAM, it is a full form of pulse amplitude modulation. is a form of a signal modulation where the signal information is encoded in the amplitude of series of signal pulses. It is an analog pulse modulation scheme in which the amplitudes of the train of the carrier pulse are varied according to the sample value of the message signal. Demodulation is performed by detecting the period level of carrier at the same symbol period. Time domain, this is the FAM is occupied. The image shows the FAM process. Signal shown of FAM, when the sign is high, the positive of the rectangular pulse is increasing. When it is low, the negative of the rectangle phase is increasing. In the noise aspect, this type of signal is easily affected by the noise. This type of flat top sampling signal. Sampling methods in FAM: ideal sampling, flat sampling. Ideal and natural sampling are eliminate noise. Ideal sampling is difficult to generate. Thank you. Please like, share and subscribe my channel.